Welcome to video on section 2.2. This is on analyzing conditional statements. So conditional statements is like it's like an if-then statement. If you were to say like, if blah, 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 then blah, blah, blah. So for example, if I were to say, and those who are Sacramento Kings fans, you may like this. If the Kings change owners, we're talking about the Sacramento Kings, not the LA Kings hockey team. They will make the playoffs next year. And it is pretty sad. You guys haven't made the playoffs in 16. I say you guys because I'm a Warriors fan. I grew up in the Bay Area. I went through my hard times. But as a Sacramento resident now, I've been in Sacramento for 2 years. I love to see the Kings make the playoffs. And fun fact, the current owner actually lives just a block or two away from the school where I work in the Bay Area. It's pretty much this big compound. And I believe he goes to the Pete's coffee shop that's in the downtown area near my school. It's in Menlo Park. And I think he takes a private jet up to the games. Yeah. And another fun fact, one of the original owners of the Kings, back when it was more of a grassroots organization, there's a bunch of local businessmen who wanted to bring a basketball team to Sacramento back in the early 80s. And they were able to lure, at that time, the Kansas City Kings. And prior to that, I think they were the Rochester Royals. But anyway, one of the original owners of the Kings is actually my next door neighbor. Not super wealthy, but he does well. I believe he's kind of retired. He's shared some interesting stories with me. So anyway, if you want to talk basketball, talk all that stuff when we're in person again. Definitely love to have that kind of conversation. I love sports, love talking basketball. But anyway, this is a conditional statement. I know I'm digressing a little bit. So yeah, so if we look here, if the Sacramento Kings change owners, that's a condition. We call it the condition, and that's the conclusion after the then part. So the condition is that if the Kings do this, then you'll make the playoffs next year. Or I do with my kids, like I say, if you are quiet during our car ride, then you get candy. And of course, I need to follow through if they're quiet. And I don't follow through if they're not quiet. Another good way of looking at conditional statements would be this. If you live in Sacramento, then you live in California. And that is true, because Sacramento is a city in California, right? But what if I reversed it? Actually, we'll talk about the verse part later. I won't confuse you guys. So let's look at this here. If xy equals yz, then y is the midpoint of xz. So let's look here. Let's draw a segment, my bad. So it seems like that would work, right? However, it didn't have to be all in one line. What if I did this? Here's xy, here's yz. Y is not a midpoint because y is not even on xz. Xz is right here, right? So anyway, that would be a counterexample. So you'll try number 2 on your own. We could talk, but there's no answers for the evens here, but we can talk about it when we meet up again later in the day around 12 o'clock. So again, the hypothesis or the condition, same thing, is if part. The conclusion is the then part. If it is rained, then there are clouds in the sky. Okay, so it's a logical statement. So rewrite these in if-then format. All birds have feathers. You can say if an animal is a bird, then it has feathers. So, you can think of this as your hypothesis. If you're a bird, you have feathers. So this one, two animals solitary if they are a linear pair. Okay. So if two angles form, because you see the if part right there, the linear pair, then those two angles are supplementary. And by the way, one other thing I'm kind of just thinking of right now is that why are we doing this? A lot of geometry is about proving statements. And in order to prove statements, you need to have prior statements that you know are true to lead you to the conclusion. So what we're going to do ultimately is like I might give you like some sort of shape. And I'll say like, here's like A, B, C, and here's D. And maybe you have to prove that like ABD is the same triangle as BDC or something like that. And I give you some information that's true about the diagram. So you have to be able to logically conclude or deduce that, okay, from what I'm given, this leads to this. Kind of like what a lawyer would do, like if a lawyer's defending somebody or making a case, like a very famous case, which is well before you guys were born, was a O.J. Simpson trial back in the mid to late 90s, or more like mid 90s. And, the defense said, well, if O.J. Simpson was not here at this time and not here or didn't do this or was here, then he didn't kill his wife and this other person, right? And so that's kind of what you're trying to do, is you're trying to work your way to making conclusions. But in order to do that, you have to understand if-then statements, like if this happened, then this happened. So that's why we're talking about this. These are kind of the building blocks. So I want to make sure you guys get the big picture. Building blocks for geometric proofs, which is actually a very big deal in this class. It kind of defines this class, at least the first 2 or 3, or first semester, which is actually the first 2 to 3 weeks of this class. And then we do more algebra, more calculations and stuff in the second semester, or the final 2 to 3 weeks of this class. So again, you guys will try these here. And just to kind of give you a little hint, you think this is the if part, and that is the then part. And then we could talk about it when we come back from our break. Or meet up again at 12 o'clock after you guys done some practice on your own. Meaning the rest of these worksheets. Negation of a statement. Excuse me. That's when you're saying the opposite. So if the ball's red, the ball's not red. The cat's not black. The cat is black. So you're just saying the opposite, that's all. That's called negation. Converse is when you switch hypothesis and conclusion. Inverse is when you negate both hypothesis and conclusion. Contrapositive is when you do both the converse and the inverse. So let me give you guys a good example here. Let's go back to that Sacramento one again. And I knew I was good in stopping myself and going too deep with it because I don't want to confuse you guys. If you live in Sacramento, then you live in California. Assuming there's not a Sacramento in Texas or Oregon or something like that. If you live in Sacramento, then you live in California. Pretty great. Well, if I were to say, if you live in California, then you live in Sacramento. And we put a couple more statements here. If you don't live in Sacramento and don't live in California, then one more statement. If you don't live in California, don't live in Sacramento. Okay, so this is our original statement. This is the converse. This is the inverse. And this is the contrapositive. Okay, this is a situation I just totally made up. And I'll call this right here A. And I'll call this right here B. So A leads to B. And this right here, I'd say B leads to A for the converse. The inverse would be negative A leads to negative B, because you negated. And then the contrapositive is negative B leads to negative A. Here's the thing. And this is very important. If the original is true, so is the contrapositive. Also, inverse and converse are not necessarily true. They could be false. But this is always true. If the original is true, so is the contrapositive. So if you live in Sacramento, you live in California. Okay, great. We know that's true, right? If you don't live in California, then you don't live in Sacramento, right? You know, maybe you live in Nevada, maybe you live in Arizona, maybe you live in Oregon, maybe you live in Washington State, maybe you live in Idaho, maybe you live in Montana, and those places don't have a Sacramento. So that would be true. I mean, we're talking about, Sacramento, obviously, where Christian Brothers is located, or where most of you guys live, right? That'd be true. If you don't live in California, you don't live in Sacramento. You live in another state where there's no Sacramento. Now here, let's look at the converse. If you live in California, then you live in Sacramento. Not really true. What if you live in Carmichael? Or if you, like, say you live like down in Modesto, or like you live in Fresno, or you live in Davis, or you live in Roseville, or you live in Rockland, right? You can be in California and live in other places. And if you don't live in Sacramento, you don't live in California, that's not true either. If you live in Carmichael, you're in Sacramento. You live in Roseville, you're in Sacramento. So those are not necessarily true. So let's look at these here. Guitar players are musicians. Well, that's true. So, if, let me type this, that'll be easier. Let's go through colors. If you play the guitar, you're a musician. That's true, obviously. Now, the contrapositive would be down here. If you are not, if you're not a musician, then you're not. Then you don't, or you're not a guitar player. And actually, let me change that one again. If you're a guitar player, there you go. So this is the if part. That's the then part. Usually put the if part first, then part second. I mean, the if part shows up first, then part shows up second. So converse. You just switch it. If you're a musician, then you're a guitar player. And then put one more statement. If you're not a guitar player, and you're not a musician. Okay. So remember, if we call this A, we call this A, we call this B. So the original is A leads to B. The converse is B leads to A. The inverse is negative A leads to negative B. And this is negative B leads to negative A. So this is true. Well, of course, if you play the guitar, yeah, you are a musician. And if you're not a musician, you're not a guitar. Yeah, of course. I mean, yeah, because then you would be a musician or a guitar player. But these are false. Because if you're a musician, you're a guitar player, you could be a pianist, you could be play the flute, you could play the clarinet, play the saxophone, play the drums, or even be a vocalist. Vocalist is music. Inverse, if you're not a guitar player, then you're not a musician. But again, if you're not a guitar player, what if you play the piano? You're still a musician, right? Or if you play the saxophone, you're still a musician. So you try the next one on your own. Okay, then we got some stuff on perpendicular lines. Just some review of, well, I'm not sure. Yeah, kind of review of old stuff, I guess. When two lines intersect, they form a right angle. Oh, sorry, let me repeat that. When two lines intersect to form a right angle, determine what happens. Got it. Okay. So this is the if statement. If two lines, and this is a symbol for perpendicular. Wait, let me repeat that one more time. Sorry. If two intersecting lines form a right angle, then are they perpendicular? Yes. Will AEB and CEB form a linear pair? Yes. Will EA and EB be opposite rays? No. That's because they're not going opposite directions. EA and EC, yes. Or this would be false. So then you try, based upon a diagram you see here. And determine if these are true or not. And then lastly, a biconditional. Biconditionals use if and only if. So this means that the converse is also true. So if I were to say, I'm trying to think of a good one here. If you are 16 or older, you are of legal age to drive. Let me write that down. We know it's true, right? In California. If you are of legal age to drive, then you are 16 years or older. That's also true. So it didn't say that converse statements are always false. It's just that they're not necessarily true all the time. But if you want to make them true, then we call it biconditional. So if A leads to B and B leads to A, both true, then we say it's biconditional, meaning you can go both ways. And sometimes we could use the word if and only if to kind of make sure that we could go both ways. So that's sometimes that's abbreviated as IFF. So you could say is that if two lines intersect form right angle, then they're perpendicular, and if two lines are perpendicular, they do form right angle. So you say you could type it like this: two lines are sometimes intersect to form a right angle. The two lines intersect, form a right angle if and only if they are perpendicular. So that's a biconditional. And you can use if you don't feel like writing all that, you could also do that also. And it means the same thing. So you'll try that on your own, and that ends this video.